This call is now being recorded.
So today I'm going to discuss about a frequently asked question by my students, and that is going to help you in your board exam for class 10 as well as class 12. So refraction through a prism, in this case, the basic thing, that angle of deviation. You see, this is the prism. This is the prism angle. This is the incidented ray in yellow color. This is the normal M in dotted white line, and I is the angle of incident. Now, if there is no prism, no as such prism, there's this yellow color ray will go, straight line, follow the straight line as per the concept of light. This is the green line which represents that undeviated ray if there is no prism there. Now, as there is a prism, so you know the law of refraction. As it enters from that air to that glass, rarer to the inside medium, the yellow color ray gets bent towards the normal. It gets bent towards the normal, towards the white dotted line. And this is the R1 refraction, angle of reflection in the first case. And this is the second case when you see the light ray, this yellow color light ray, is going to escape from the prism from that another end. And here this is R2, this angle, and there will be the emergent ray, yellow color, and this is the E angle, that is the angle of emergence. And as you see, this green dotted line is the undeviated ray. And if you produce this yellow color emergent ray, which is getting out from the prism, in produce it backward direction, it will basically intersect that undeviated ray, and this angle between these two is delta. You see the delta at P point. Okay, now first you consider this red boundaried you know quadrilateral. Here angle A, angle O are two opposite angle of a quadrilateral which sum up to a value of 180 degree, property of quadrilateral. Now angle A will be 180 minus 0, because as angle A plus angle O is 180 degree. So angle A is 180 minus angle O. Angle A is 180 minus angle O is done. Now you see this small triangle MON. There you know the property of triangle. The three angles sum up to 180 degree. So angle R plus angle R1 plus angle R2 plus angle O is 180 degree. So angle O is 180 degree minus R1 plus R2. Why we need this thing? Because we need to replace the value of angle O in the previous, that is 180 minus O. This equation is there, and there we will replace. So if we replace the value of angle over there, the previous equation, the first equation becomes angle A is equal to 180 degree minus 180 degree minus R1 plus R2. If you open the bracket, what will happen? If you open this bracket, this is negative, no problem, but this becomes positive. So this and this get cancelled. Only you have R1 plus R2. Angle A is equal to R1 plus R2. This is basically very useful thing. You need to remember this relation. Angle A, angle of the prism, is equal to R1 plus R2. Now from triangle PMN, this above this triangle, this red bordered triangle, okay, PMN. So you see the external angle of this triangle is angle delta. If you see, this is the external angle of this triangle, angle delta. And we know as per the law, this external angle will be equal to the sum of this angle and this angle, sum of this angle and this angle. Now sum of these two angle is what? See, angle I, and here is this total angle is also angle I, vertically opposite, but this below angle is angle R1. So the small angle will be what? Angle I minus angle R1. Similarly, here this is angle E. This total is angle E, vertically opposite, but this below is angle R2. So the above will be angle E minus R2. Okay. So therefore, delta as a external angle of this triangle PMN is equal to angle I minus R1 plus angle E minus R2. These two angles of this triangle PMN. Look at this triangle. If I just remove this all the annotation, you can see it clearly. Okay. So what I am saying, this angle delta is equal to this angle plus this angle, and that two angle I have defined. Just reverse the video and you can see it, the explanation. Now this delta is equal to I plus E. Why we have rearranged it? Because I and this E we have taken in one bracket, and then minus R1 minus R2 is nothing but minus R1 plus R2. So then R1 R2 is already A. We know this. So we can replace it there. So del is equal to I plus E minus A. Now this is the variation in angle of deviation with angle of incidence. So in x-axis we should keep angle of incidence, in y-axis angle of deviation. Now this is the relation we know, delta is equal to I plus E minus A. Now you see this is a specific point when this angle of deviation becomes minimum value, and when this I is equal to E, that means angle of incident is equal to angle of emergent. In that condition this will happen. Okay. Now, see, this is the normal case. I, this angle of incident, and it is coming out angle of emergent. And we know the law of reversibility for the light. So you can do in opposite way also. The light can enter from that end also, from that E, that angle of emergent end also it can enter. So see, this also can be done. Okay. Now, this minimum angle of deviation, that's more maximum students having doubt, and it is very important because the question will be asked from this particular topic, minimum angle of deviation. What is the condition, when it will happen, what will be the formula, revised formula, and what will be the problem that can be asked from this topic. See the prism again, this is the angle of the prism, this is the incidented ray, this is the normal drawn on the point of incident M, and I is the angle of incidence. Now what will happen here? This is the undeviated ray. Now here what will happen? You see the yellow color, this ray passing inside the prism is actually parallel to the base of the prism. This will happen over there, and this angle E over here, and another R1 R2. So minimum angle of deviation condition I is equal to E, or I can say sometimes this E can be written as I2 and I can be written as I1. So then you can say it is I1 plus I2. I1 is equal to I2, sorry, I1 is equal to I2. Or normally I is equal to E, angle of incident is equal to angle of emergent. And at that condition, R1 also equal to R2 is equal to R. So both the value of this R1, R2 will be equal. And this is the angle of deviation at point P. So at minimum angle of deviation, delta can be denoted by capital D subscript M. And at that condition, I will be equal to E. I will be equal to E. And the refracted ray inside the prism becomes parallel to its base. R1 is equal to R2 is equal to R. And from delta is equal to I plus E minus A. Okay. And therefore, if I is equal to E, so I can write I plus is equal to 2I, because both of them are equal, na? 2I minus A. So I becomes A plus dm by 2. And as we know, A is equal to R plus R1 plus R2, the first we have discussed. So A is equal to R1 R2 equal to R, both of them equal. So A is equal to 2R. So R is equal to A by 2. So we got angle I is equal to A plus dm by 2, angle R is equal to A by 2. Now Snell's law we can apply. Okay. From Snell's law, we know sin I by sin R is equal to mu. So I can write Snell's law like this. This n1, n or this mu are same, for both can be used to represent refractive index. So n1 means mu1 sin I is equal to mu2 sin R. So what I can do, mu2 by mu1 is equal to sin I by sin R. This is what Snell's law says. And this mu2 by mu1 is nothing but mu2 to 1 in subscript. Sin I by sin R. Now sin I, we know this value, A plus dm by 2, and sine r is a by 2. Now we know one concept for smaller value of angle, for smaller value like very very small value, then what we can consider sine theta is equal to theta. So sine a plus dm by 2 is equal to only a plus dm by 2. Sine a by 2 is only a by 2. No need to give sine because this is the property. For sine and tan we can do, but for cos we can't do. Okay. So a plus dm by 2 by a by 2. 2 to get cancelled. So I can say a plus dm by a. That is equal to mu 2 to 1. So mu 2 to 1 is equal to a by a is 1 plus dm by a. Now if I want to get dm, what I should do? First bring this that side. So mu 2 to 1 minus 1 is equal to dm by a. Now multiply this a with this. So dm will be equal to mu 2 to 1 minus 1 into a. This is very important formula. This is very important formula for minimum deviation. If the refractive index given, prism angle is given, directly you can get this, minimum deviation. So that is what here also it is described. But only mu is actually denoted here with n. Both of them are same only. Whatever I have written over there, that is here it is said. Now ready for the challenge. This is the concept test. Here this is the question. Find the minimum deviation caused by a prism having a prism angle 4 degrees. So this is A actually. And refractive index 3 by 2. This is mu 2 to 1, that thing. And assuming surroundings medium as AR. So that actually AR is 1. So I can do that thing. Now you see refractive index is given 3 by 2, prism angle this. So we know the formula dm is equal to mu 2 to 1 minus 1 into a. Actually mu 2 to 1 is 3 by 2 because why, you understand this thing, mu 2 by mu 1 is equal to mu 2 to 1. Now mu 2 is given 3 by 2 and mu 1 is what? Mu 1 is here actually. This is mu 2, that is 3 by 2. Mu 1 is here, that is AR is 1. So mu 2 to 1 is eventually 3 by 2. 3 by 2 is equal to mu 2 to 1. So you replace 3 by 2 minus 1 and this A is 4 degree 4. So 3 by 2 minus 1 is what? Half and 4 degree. So 2 degree is the answer. 2 degree is the answer. So this type of question can be asked. So that's all for today, students. So more videos like this will come for you to support you in your board exam. Thanks for watching.